Right, so we are moving on to section 8.1, so on to chapter 8. First section is going to be working with non-right triangles using the laws of sines and the laws of cosines. Now, this is something that you probably have seen at least once in geometry, worked with a little tiny bit. So for part 1, we are going to be working with the law of sines. So this will be our part 1. And then part 2 will be law of cosines. So we'll be moving on to that. So how do we know which one we need to use? So we're going to look at what information we're given. If we are given a triangle and the information angle, angle, side, then the law of sines will work. If we are given angle, side, angle, we can use the law of sines. And if we're given side, side, angle, we can also use the law of sines. However, this one, we are going to have a lot more information for this one. This is not the easiest one. You may remember from geometry that there's not enough information given in this to be definite about a triangle. So there's a lot of options and a lot of things that can happen with a triangle given the information side, side, angle. Then over here on the law of cosines, if you are given side, angle, side, then we're going to have to use the law of cosines. And if you're given side, 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 then we're going to have to use the law of cosines. So these will be the options that we cannot use the law of sines. The law of sines is a lot easier to use and to go with. And so we're going to use the law of sines as much as possible. So on the formulas, the law of sines is the sine of A over side A equals the sine of B over side B, which equals the sine of C over side C. So really, really easy formula to remember. You can also flip, if you flip all of them, you can also do side A over sine A equals side B over side B, and so on. So either one of those, however it works, maybe it's easier sometimes to use these. I always tend to just go with this one and then solve my equations however I need to from there. Okay, then it also says down here, this is where we have to look for the ambiguous case. Remember, bad word. So, of course, I'm sure you remember in geometry or just from looking at this, we could also say that this is angle, side, side. We don't put it that way because we don't want to use bad acronyms in math, but that's how we know we are going to have an ambiguous case. Okay. Okay, really quickly, I'm going to show you how we get the law of sines. So normally we would just use cosine, sine, and tangent if we had a right triangle. The case in this chapter is we're going to be working with triangles that are not right triangles. So we have to go a little bit farther into each one of these definitions. So let's say we have a triangle that is not a right triangle, this one right here. And what we're going to do is we're going to go in and we're going to drop in a height. Okay, so now we have two right triangles within our triangle. We have this one on the right, and we also have the right triangle on the left. So if we have right triangles, we can go ahead and just use sine. So using the right triangle relationships, we have that the sine of alpha, so sine is the opposite over the hypotenuse. So sine of alpha is equal to h over b, and then sine of beta is equal to h over a. So from there, let's solve both of them for h and set them equal to each other, and I'll show you how we have come upon the law of sines. So we have b, hold on. So we have b sine of alpha equals h, and then a sine of beta equals h, and then set them equal to each other. Since they both equal h, we have b sine of alpha equals a sine of beta. Now I'm going to divide both sides by a and b. I could do that in 2 steps. I'm trying to solve for sines. So I could divide this one by a, and then this one by B, and then do them both. But anyway, we're just going to do them in one step. So what happens is our B's cancel on the left-hand side, our A's cancel on the right-hand side, and we have the sine of alpha over A equals the sine of beta over B. And that's how we prove our law of sines. So moving on to example 1, we have given the triangle below, find the length of side x using the law of sines. So let's look at the information that we're given. We are given an angle, and a side. So that is one of the types of triangles that we can use the law of sines for. So we're going to have the sine. I'm going to start off with my paired sides. So I'm given the angle of 27, and I'm also given its opposite side. So I'm going to start off with that one because that is a complete ratio. So the sine of 27 over 18, I know both of those. And then that's going to equal the sine of 46 over x. Okay, and then from here I need to solve for x. So this is an example of where I could have used my sides in the numerator since it's the sides that I'm looking for. To me it really doesn't matter because I'm just going to cross multiply and solve everything anyway. But that is up to you guys. That is an option that you can do. Just for some reason I always tend to just do it this way. So we go with x sine of 27 equals 18 sine of 46. And then divide both sides by sine of 27. And so then we end up with x equals all of that, and my calculator. So make sure that you are in degrees on this. So I'm going to have to change my calculator to degrees. The last thing I did was in radians. So I have 18 sine of 46 divided by sine of 27. And I get 28.521. And so that is for my side, my unknown side. That is not a degree angle. It is a side. Okay, so x equals 28.521. And let's go on to example 2. Alright, so example number 2, we have used the law of sines to solve the triangle for angle A equals 38 degrees, angle C equals 73 degrees, and side B equals 25. So we are given an angle, and a side, but also notice that none of them are directly across from each other. So I don't have any paired sides, an angle paired with a side. So I have angle A, angle C, and side B. So what I really need to know is what is angle B. But we can figure that out easy enough because we're already given two angles. So angle B is going to equal 180 minus the sum of 38 plus 73, because all angles must add up to 180 degrees. So we have 180 minus 38 plus 73, which is 69. So I have the measure of angle B is 69. Oops, that's not how I meant to write that. Let's try that again. There we go. And that's in degrees. So now we can write that as the sine of 69, because we want to start with our paired side, our angle side that are given, over 25, which is equal to the sine of 38 over A. And then let's go ahead and solve this one first, and then we'll go back and do another ratio equation with angle C so that we can find side C as well. So we want to solve for all sides of this triangle. Okay, so sine of 69 over 25. And actually, let's go ahead and just make it an equation. So we have A sine of 69 equals 25 sine of 38 divided by sine of 69. And so then we know what A is. A is going to be 25 sine of 38 divided by sine of 69. So I'm going to write up here so we can keep track of our answers. So I have side A is equal to 16.4866. And then we also found the measure of angle B to be 69 degrees. Alright, so now we've got all three angles. We've got two sides, so we need to solve for our last side. I'm going to start off with the same angle that we were given to begin with. So sine of 69 over 25. So start with the pair that we know equals the sine of 73 over C. And then solve again. So we have C sine 69 equals 25 sine of 73 divided by the sine of 69. And so we get 25 sine of 73 divided by sine of 69. And so we get C equals 25.6085. And so that is all of the information. Now we have everything that we need to know about this triangle. And so we're done with example 2.